Hello, this is Gareth Williams, and this is my second video on how to configure Ospf and Frame Relay. In my previous video, I demonstrated how to configure Frame Relay using point-to-point interfaces, and then Ospf then on top of that. In this video, I'm going to demonstrate how to configure multi-point interfaces and what needs to be done with Ospf then. It is slightly different to the point-to-point sub-interfaces that we had to do. Okay, so this is our network topology. It is slightly different. One thing to bear in mind is with the multi-point interfaces, each the R1, R2 and R3, these serial interfaces will need to be on the same subnet so they can actually talk to each other. I've gone ahead and modified the frame relay switch, and I've gone ahead and configured the IP addresses on the routers as well as the loopbacks, and so all we need to do then is configure frame relay and Ospf. So if we have a look at show IP interface brief on R1, see that? Okay, so we're in an up-down situation. Okay, so let's have a look at R2. Same situation there, and R3. And we're in the same situation, up, down. Okay, so one thing about the configuration of frame relay using this type of network, this frame relay network, is that we don't use the frame relay interface delc command. What we actually need to do is configure the frame relay map using the command frame relay map IP. Then we need to say the destination IP as well as the local delc number. So we start off on R1 config terminal. We need to change the encapsulation. Let's go under the interface. We need to change the encapsulation to frame relay. Now, I think I mentioned this before. If you want to connect to non-Cisco devices, you need to use this IETF option. But since we're using Cisco, we're not going to bother. And also, I think I mentioned this as well. Type. Yeah. So the LMI is the language of frame relay. We're going to be using Cisco, but you do have other options there, and they do need to match. But we're going to stick with the default Cisco. So I can delete that. Now I've changed the encapsulation. Now I need to do the actual frame mapping. So we'll do frame map IP. So I'm going to go to R2 first, which is 1.2, which is using the local delc of 101. Now, because we want multicast traffic to go over this, we're going to have to use the keyword broadcast. So this broadcast keyword will allow broadcast and multicast traffic to go over the frame relay network. Remember, the frame relay network is a non-broadcast multi-access network. So we need to put that in there by default. Well, we need to put that in there for routing protocols to work. And again, if we're connected to non-Cisco devices, we'll need this IETF, but we're not going to bother. And I'm going to do 2.3, and this delc is 102. One thing to bear in mind is a similar sort of setup as before. So the way that I've configured the frame relay switch is that the PVCs will go R1 to R3, R1 to R2, but not between R2 and R3. So for traffic to go from R2 to R3, it will need to actually go through R1 back down to R3 and vice versa. So yeah, let's have a look at this now. So R1 looks like it's done, so let's go to R2. encap frame relay frame map IP 192.168.1.1 using the local DLC of 202, and again I need that broadcast, and I need to tell it how to get to R3 as well using the local DLC of 202. That's it. This is R3. Again, encapsulation frame relay. Frame map IP 192.168.1.1 using the local DLC of 303. Oop. And I want to say how to get to R2 using the local DLC of 303. Now that should be it. We'll try pinging. Okay. Yep, that looks good. Yep. Yep, and yep. Okay, so frame relay is done and configured. One good command to use to verify frame relay is the show frame relay map. So we're on R1, so we've got two DLCs here. They have been statically assigned. We've got the important keyword there, broadcast, and it's active. Yep, so that is good. We can just do it on this one as well. Frame map. Yeah, so that's good. Static, broadcast, and active. Show frame map. Yeah, static, broadcast, and active. Yep, that's good. So let's go ahead and configure Ospf. I'll give it a static router ID. Now what? Okay. Show IP INT brief. See what networks I've got here. Network 192.168.1.0. Area 0. Network 10.10.1.0.0. Match. I don't care. Area 1. Yep. Now there is additional configuration I will need for Ospf, but I'll come back to that. So this is how you would configure Ospf normally over a broadcast network such as Ethernet. So we'll go under router ID, router Ospf1, router ID 2.2.2. And we'll do a do show IP interface brief. Network 192.168.1.0. Area 0. Network 10.2.0.0. Match. I don't care. Area 2. And then 192.168.1.0. Area 0. And net 10.3.0.0. This is area 3. Okay. So let's have a look at the show IP Ospf neighbor. Okay, that's not a good sign. Okay. No, not a good sign. Not a good sign. Okay, so because this is a non-broadcast multi-access network that we're going across, we're going to need some additional configuration. Show IP Ospf interface. See that? Non-broadcast there. So we're going to have to sort that out. Because this is the hub. This is the hub and these two are the spokes. So I'm just going to put a neighbor statement here. Neighbor 192.168.1.2 and 3. And let's see what happens now. Show IP Ospf neighbor. Okay, so we've got an attempt. An attempt is sending unicast packets over the non-broadcast network. I think it's the second stage. And there we go, this folder. That's good. Xstart. We're just waiting. And there we have it. Okay, so let's have a look at this here. So we've got a DR and a BDR here. So let me just have a look. Show IP OSPF interface. Okay, so it's seeing itself as DR other, so it's not a DR or a BDR. So non-broadcast, the cost. This is telling us who the designated router is. So it's R2. We're on R1. Let's have a look here. It's seeing R1 as the BDR. Yep. And the same here as well. So we're gonna have to sort that out because we don't want. Which one is the? Okay, so designated router is R2. Okay, we don't want R2 to be the designated router because this is a hub and spoke where the PVCs are all connected to R1. Yeah, so if R1 was, if anything was happened to R1, then you know obviously R2 and R3 won't be able to communicate with each other. So there's no point to R2 being the designated router, and well, yeah, R1 is the BDR, but we don't want that. We want R1 to be the designated router. So how do we do that? Well, we need to configure the priorities of R2 and R3. We could leave the priority as default on R1, but we'll change that. Now to change the priority, you need to go under the interface, IP OSPF priority. We'll give this a priority of 10. The default is 1. Yeah, but we're going to change it to 10. And we don't want R2 and R3 to even be considered to be elected for a DR or BDR. To do this, we'll do IP OSPF priority 0. 0 means do not even attempt to elect me. OSPF priority 0. And then let's see what happens. Show IP OSPF neighbor. Okay. Yeah, see that is changed there. Okay, so now we're seeing R1 as the DR. So I show IP OSPF interface. Okay, so now it sees itself as a designated router. If we have a look above here, we did see R2 as a designated router. We did see R3 as the BDR. and R2 as the DR, and now it's all good. Oop. So the DR other is that it's not a DR or BDR. So that is about it. So let's have a look at the routing table here. Let's try ping some things. Yep. Yep. Two dot one, and let's try 3. Yep. Yep. And yes, so we have full connectivity. Let's just have a look at the running config. Show run dash section Ospf. So the important thing here was the neighbor statement. Yep. And if we go under, so I've increased the priority to 10. It was 1. And that is about it. Yep. Thank you for watching.